Welcome to this session. Today we are going to discuss some more problems on first order recurrence relation, and then after that we will start the second order recurrence relation by using method of generating functions. Here let us consider one of the problem. Just we are concentrating the first order recurrence relation and how to solve by using generating function. See, this is the continuation of the last session. So we are going to solve one or two problems on this. After that, we will go for the second order recurrence relations. Now, here, this is the given equation can be written as a n plus 1 is equals to a n. Just we are going to substitute n is equals to n plus 1. So I am going to get this. So just which is for n is greater than or equals to 0. Then this I am going to write it as an plus 1 minus an is equals to 2n. This is for n is greater than or equals to 0. Call this as 1. Now, for this, the generating function which we discussed in the previous class, the f of x is equals to then a naught plus x into g of x by 1 minus cx. Here c is equals to 1. So a naught is equals to 1. So it is 1 plus x g of x by 1 minus x. So this is the generating function. Now we are going to calculate what is g of x. After that, we are going to substitute and we are going to express. So where g of x is equals to, so it is phi of n. So phi of n we have summation n is equals to 0 to infinity, then 2n x to the power of n. 2n into x to the power of n. Now I just took 2 as common. Then the remaining thing is n x to the power of n. N is equals to 0 to infinity. Then I am going to expand this by taking n is equals to 0, 1, 2 and so on. N is equals to 0. This will become 0. So n is equals to 1. So it is 1 into x plus 2 into x square plus 3 into x cubed plus 4 into x power 4 plus and so on I am going to get. So this I am going to write it as 2 into x I took common. Then it is 1 plus 2x plus 3x square plus and so on I am going to get. So this is nothing but just this is the expansion of it is 1 minus x whole to the power of minus 2. So now g of x value is equals to this. So 2x and this is 1 minus x. The whole expression is equals to this one. Now I am going to substitute in equation 2. So f of x I am going to write it as. So 1 plus x is equals to x will be the same and g of x is 2x into 1 minus x whole to the power of minus 2 by 1 minus x. Then this I am going to write it as 1 by 1 minus x and this is 1 plus 2x square by 1 minus x whole square. This I am going to write in this way. Now afterwards, this is equivalent to 1 by 1 minus x. This I am going to take it as, what is that? 1 by 1 minus x. This is 1 by 1 minus x. And then this is 1 minus x whole square minus 2x square. So 1 minus x whole square, then it is a minus 2x square by 1 minus x whole square. So this is just, I am going to expand it. So 1 minus x and whole square, this will be x power cube. Then it is 1 plus x square minus 2x minus 2x square. So which will become 1 minus 2x and minus x square. So this is, and of course this we are going to write it as into 1 minus x whole to the power of minus 3. Then this once again I am going to multiply this 1 minus x whole to the power of minus 3 minus 2x into 1 minus x whole to the power of minus 3 minus x square into 1 minus x whole to the power of minus 3. Now this is already we know this is a 1 minus x whole to the power of minus n formula. So it is a n plus r minus 1. So 3 plus r minus 1 CR x to the power of r. R is equals to 0 to infinity. Then minus 2x, and this I am going to write it as 3 plus r minus 1 CR x to the power of r. And this I am going to write it as in the same way summation 3 plus r minus 1 CR and x to the power of r. So this is 2 plus r CR and x to the power of r summation r is equals to 0 to infinity, then minus 2, then this will become 2 plus r CR, then x to the power of r plus 1 minus, this is 2 plus r CR, then it is x to the power of r plus 2. Now this is f of n. F of x, this is f of x. So what is f of x? F of x is nothing but summation of an x to the power of n. So of course we are going to get, this is the generating function, whatever this is the generating function of the given sequence. So we are just saying that this is the generating, or else we can consider any one of this. This is the generating function. Then we are now going to solve the generating function. So for that we are going to consider f of n. F of x is equals to an x power n. So because it is a generating function for the sequence a0, a1 and so on, an and so on it will be. So for that I am just comparing the coefficients of x to the power of terms on both sides. So I am going to get an is equals to here an. So for what value of r it will become x to the power of n, that we have to take. So first one is r is equals to n. So it is nothing but nc2 cn and x to the power of n minus 2 into, here it is n is equals to n minus 1 we have to consider, because n minus 1 plus 1 it will become n only. So I am going to write r is equals to 2 plus, and r is n minus 1 and cn minus 1. Then here n minus 2 we are going to take it as plus 2, n minus 2, n minus 2. So this is the, just we are considering x to the power of n coefficient. So then this is n plus 2 cn, then this is minus, and this is n plus 1 cn minus 1 minus n cn minus 2. So here what about that? So this is minus 2x square, and here it is then this is the, what we are going to get, it is what about this? This is, sorry, here it is a plus will be there, and I just took here minus, sorry, it is plus, so it is a plus. So we are going to get, this is a plus 3x square, so this is a plus 3x square, so this is a plus 3x square, So it is plus 3. So it is plus 3. So this is plus 3. Then this is just we are going to consider what is n plus 2 Cn. It is nothing but n plus 2 only. So it is a n plus 2 factorial by n plus 2 minus n. It is factorial. So it is 2 factorial into n factorial minus 2 into n plus 1 factorial by n plus 1 minus n minus 1. So n plus 1 minus n minus 1. So it is a n get cancelled. So I am going to get 2 factorial and n minus 1 factorial, then plus 3, then it is n factorial and it is 2 factorial, n minus 2, and next n minus 2 factorial. So this is n plus 2 into n plus 1 and into n factorial. This n factorial will get cancelled. So it is 2 minus 2 into n plus 1 into n, and by 2 will be there, and next n minus 1 factorial will be cancelled. So n into and n minus 1, and that is n minus 2 will be cancelled here. By taking this, I am going to get this. So this is after simplification. Finally, we are going to get it as 2n square minus 2n plus 2. So after that, just 2 has to take common. So n square minus n square, this is a minus n, and then it is a plus 1, which is the solution for the recurrence relation in generating function. So here, first of all, we are going to write what is the generating function for the given sequence. So this is the generating function we are going to get, and we have to solve, hence solve it. So for that, the solution I am going to find an, and an we are going to get finally an as this. So this is the solution for that. And let us go for the another example, and this is the second first order recurrence relation. Now see, in the same way we are going to solve as like the previous one. So here it is c is equals to 3, already it will be there, just I am going to substitute n is equals to n plus 1. So it will become a n plus 1 minus 3 a n is equals to n plus 1. So this is n is greater than or equals to 0. So the given equation reduced to this by taking n is equals to n plus 1, because we derived the expressions for the f of x function, which is for this. So we are going to write the given expression like this. Then c is equals to, then what we are going to get, it as c equals to 3. So what is the f of x is equals to? F of x is equals to, so it is a naught plus x into g of x by 1 minus cx. So a naught is equals to 1, it is given, and x g of x by 1 minus 3x. 1 minus 3x. Call this as equation 2. Now we have to find g of x is, where g of x is equals to summation of phi of n. Phi of n is equals to what? This is n plus 1. n plus 1 into x to the power of n, and of course n is equals to 0 to infinity. Now if I am substituting n is equals to 0, then I am going to get 1. N is equals to 1, and I am going to 2x. N is equals to 2, 3x square. N is equals to 4, 4x cubed, plus and so on I am going to get. So this is nothing but the whole expression. This is nothing but the expression of 1 minus x whole to the power of minus 2. So I am just substituting in equation 2. So from equation 2, then I am going to write f of x as 1 plus x. G of x is 1 minus x whole to the power of minus 2 by 1 minus 3x. Now this is 1 by 1 minus 3x is into 1 plus x by 1 minus x whole square. 1 minus x whole square. So this is 1 by 1 minus 3x, and now I'm just multiplying. Straight away I'm going to multiply. So x into 1 minus 3x into 1 minus x whole square. So call this as equation 3. So this is the generating function. This is the generating function. Now I am going to find out the solution for this. For that, we are going to split this by using partial fractions, because I need to calculate what is an. So for that, I required to written the whole thing as something to the power of 1 minus x to the power of minus n form. So for that, I am going to write this by using partial fractions. Then I am going to take it as 1 minus 3x and then 1 minus x whole square. This can be considered as a by 1 minus 3x plus b by 1 minus x plus c by 1 minus x whole square. 1 minus x whole square. Then this is just I am taking as x is equals to a into 1 minus x whole square plus b into 1 minus 3x into 1 minus x and c into 1 minus 3x. So this I am going to take LCM get cancelled each other. So x is equals to I am going to get this. So now I am just to substitute. Straight away I can substitute x is equals to 1 in this expression. Then I am going to get, if x is equals to 1, suppose if x is equals to 1, then what I am going to get, 1 is equals to a will be 0, b will be 0 and c into 1 minus 3. So what I am going to get, minus 2c is equals to 1. So c is equals to minus 1 by 2. Similarly, if I am going to substitute for what value of x, a or b will be vanished. For that value we are going to calculate, or else straight away we can consider the coefficients of constant terms, x terms and x square terms we are going to take, and from that also we can calculate this. And now if I am going to take x is equals to 1 by 3, if I am going to consider, if x is equals to 1 by 3, then I am going to get, this is 0 and this is 0. So 1 by 3 is equals to a into 1 minus 1 by 3 whole square. So it is nothing but a into, so it is 2, 3 minus 2, it is 2 by 3 whole square. So it is 1 by 3. So subsequently a is equals to what I am going to get. So 3, 3, 3, so it is nothing but we are going to get 3 by 4. 3 by 4 we are getting. And next, similarly, we can calculate the value of b. The value of b, again we are going to get minus 1 by 4 in this fashion, or else some other forms if you are going to calculate. Then after finding this, so what I am going to get, after finding a, b, c values, then I am going to write x by 1 minus 3x into 1 minus x whole square, which is equals to a by, so a is equals to what I am going to get, 3 by 4. So it is 3 by 4 into 1 by 1 minus 3x. Then b is equals to minus, b is equals to minus 1 by 4. So minus 1 by 4 into 1 by 1 minus x, and c is equals to minus what we are going to get, minus 1 by 2. So it is minus 1 by 2. This I am taking it as minus 1 by 2 into 1 minus 1 by x whole to the power of minus 2. So now this is, I am just taking this as, this is the given expression. So what about f of x is equals to, what is f of x is equals to? See here, f of x is equals to, from equation, what I am saying, equation 3, from equation 3. So it is 1 by 1 minus 3x, and next plus the whole term, the whole things. So same as it is. Now this is 1 minus 1 by 1 minus 3x. If I am just taking common, so 1 plus 3 by 4, it is only 4. 4 by 4, so I am getting it is 1, and next minus 1 by 4, and this is 1 by 1 minus x, and minus 1 by 2, 1 by 1 minus x whole to the power of 2. And this can be written as 1 minus 3x whole to the power of minus 1, 1 by 4, 1 minus x whole to the power of minus 1, 1 by 2, 1 minus x whole to the power of minus 2. So now this will become, this is 1 by, this is 1 plus 3 by 4, it is 7 by 4, it is 7 by 4, not 8 by 4, and it's not is minus, it's plus only, so 7 by 4, so I am getting 7 by 4, 1 minus 3x whole to the power of minus 1, this is also 7 by 4, and this is 1 minus 3x, 1 plus 3x plus 3x square, and so on. So this I am going to write 3x whole to the power of n. N is equals to, of course, 0 to infinity. 0 to infinity. Then minus 1 by 4. This is a summation x to the power of n. And of course, I am just taking r, x to the power of r. Then just I am going to consider it as r is r. So x to the power of r equals to 0 to infinity. Then 1 minus 1 by 2. Then this is the next one is n plus 1. This I am going to write it as n is equals to, r is equals to 0. R is equals to 0 to then infinity. Then it is r plus 1, and x to the power of r. R plus 1, x to the power of r. Now, this is f of n is equals to summation of an, x to the power of n. Now, x to the power of n coefficient terms I am going to compare. So, an is equals to, then it is equals to 3 to the power, r is equals to n. So, it is a 7 by 4, 3 to the power of n minus 1 by 4, x to the power of n is 1, minus 1 by 2, then r is equals to m, so n plus 1. So this is the required solution for the given recurrence relation, or else if you want to simplify further, so 3 power n, so minus n by 2, this is minus 1 by 2 minus 1 by 4. So it is a minus 3 by 4 I am going to get. Either you can keep that, or else this is the simplified version, of the above relation. So this is the solution of the given recurrence relation. Now, with this, we are just going for the second order recurrence relations. Method of generating functions for the second order recurrence relation. Now, let us consider, I am just taking second order recurrence relation form is, let us consider the recurrence relation. Suppose the recurrence relation is to be solved, which is of the form an plus an minus 1 plus ban minus 2 and is equals to f of n. So which is the for n is greater than or equals to 2. N is greater than or equals to 2. And then here A and B are constants. So which is the second order second order recurrence relation. Or equivalently I am going to write it as A n plus 2 plus A n plus 1 plus B A n is equals to f of n plus 2, that I am taking it as phi of n for n is greater than or equals to 0, and where phi of n is f of n plus 1. So now this is the given second order recurrence relation. Now here A and B both are constants. Now we are going to apply generating function. Now we are going to convert what is a generating function for the second order recurrence relation. So for that I am going to multiply each and every term of this recurrence relation by x to the power of n plus 2. So A n plus 2 into x to the power of n plus 2 plus A n plus 1 into x to the power of n plus 2 plus B A n x to the power of n plus 2 is equals to phi of n x to the power of n plus 2. So just equation 1 is multiplied with x to the power of n plus 2. Afterwards, take the summation on both sides from n is equals to 0 to infinity. Then this is n is equals to 0 to infinity. Then this is n is equals to 0 to infinity. Then this is n is equals to 0 to infinity. Now, then this is first n is equals to 0. What I am going to get? A to x power 2. So this is equivalently I am going to write it as, then I am just taking summation n is equals to 2 to infinity a n x power n. Just I am equivalently written as summation n is equals to 2 to infinity. Then here I am going to write it as, the same way. A is a constant, take it outside. Then x also I am going to take it outside. So ax I am taking, so a n plus 1 x to the power of n plus 1. So this I am going to in a similar manner. N is equals to 1 to n infinity and a n x to the power of n. So this is equivalent to this. Now the another one is, what I am going to take, b is a constant, take it outside, and x square also I am going to take it outside. Then n is equals to 0 to infinity. Then a n x power n, which is equals to, once again I am taking x square summation n is equals to 0 to infinity phi of n and x power n. Now here limits are n to 1, 0 to infinity here, n to 1 to infinity here, 2 to infinity here. So I am going to convert. The limits are from n is equals to 0 to infinity. For that, I am going to write this as n is equals to 0 to infinity a n x to the power of n. So for that, I am just taking two terms I am going to add, a naught. So I am going to subtract a naught. Next, a1, I am going to, a1x also I am going to add it. So a1x. So this is equivalent to this. Then plus a of x. Then this is summation of a n x power n. N is equals to 0 to infinity. Then for this a naught I added. So a naught I subtracted. So this is this one. And of course the remaining I am going to write same as it is, bx square summation an x power n, and of course I am going to take it as is equals to x square g of x, where g of x is equals to, then I am taking it as summation phi of n x to the power of n is equals to 0 to infinity. Now here I just took common as a naught an x to the power of n as a common from this term and from this term and from this term. So what I am going to get, a naught x to the power of n, I just took common. Then what I am going to get, the first one is 1 and the next one is plus ax and the next plus bx square into summation an x power n is equals to 0 to infinity. Then this the remaining things I am going to take that side. So what I am going to get, this is a naught I am taking to that side and a1x, and here ax term is there and here x term is there. So what I am going to take it as this, I am going to taking to right hand side. So a1 and then plus a naught a into x, and then the other one is x square g of x. So now this I am going to write it as an x to the power of n is equals to 0 to infinity, which is equals to a naught plus a1 plus a naught a into x plus x square g of x by and a plus ax plus bx square. So this is, of course, I am going to consider this is a generating function. Let that generating function, I am going to take it as f of x is equals to, then what I am going to get, a naught plus a1 plus a naught a into x plus x square g of x by 1 plus ax plus bx square. So here a naught, a1 are the conditions which are given in the problem itself, and a, b both are constants, and where f of x, what is f of x? We assume it as some generating function for the sequence a naught, a1, a2 and so on, n is equals to 0 to infinity. So this is the generating function for the second order recurrence relation. So first of all, whenever any second order recurrence relation is given, which is of this form, then we have to find the recurrence relation as like this, where f of x is this and g of x is what? Phi of n x to the power of n. And what is phi of n is? Phi of n is equals to f of n plus 1. Phi of n is equals to f of n plus 1. So we have to substitute and we are going to solve the first of all we are going to write in the recurrence relation. After that, to solve this, we are going to consider x to the power of n terms on both sides. Subsequently, we came to know what is the solution which we solved in the first order recurrence relation. Similar to that. Now here, if f of n is equals to 0, then the recurrence relation is homogeneous. So whenever if it is a homogeneous, then the generating function f of x is equals to a naught plus a1 plus A naught A and X, and of course this term will vanish, and y 1 plus AX plus BX square. So this is the generating function for the homogeneous recurrence relation. Homogeneous recurrence relation. If it is non-homogeneous, it will be given. Then we have to calculate g of x. Otherwise, we just calculate what is g of x in the place of g of x. We put it as 0 because there is no function. F of n is 0 means there is no function, means f of n plus 1 is also 0. Subsequently, phi of n is also 0. Phi of n is also 0. So we can say that this term will vanish. So subsequently we are going to get this. Now let us go for one problem. Find the generating function and solve the recurrence relation. Find the generating function and solve the recurrence relation. So here for this problem, let us, I am just taking in the standard form as by taking n is equals to n plus 1, n plus 2. So what I am taking, because it is n is greater than or equals to 2, n is equals to n plus 2. If I substituted, then it is a n plus 2, and next plus a n plus 1 minus 6an is equals to 0. This is for n is greater than or equals to 0. So what is our standard form is? This is a n plus 1 coefficient is a n plus 1 coefficient is a. Here what is a is equals to? A is equals to 1 and b is equals to what? So b is nothing but an coefficient. So b is an coefficient. So what I am going to get, b is equals to minus 6. B is equals to minus 6. Then what is the recurrence relay? What is the generating function for this? F a homogeneous one, because the given equation is a homogeneous. There is no function on the right hand side. So it is a homogeneous. So what is the recurrence relation? What is the generating function for homogeneous? This is the generating function. Now we are going to write it as f of x is equals to f of x is equals to a naught plus a1 and plus a naught a, and of course it is x by 1 plus ax plus bx square. Then what is this is a naught is given as minus 1, a naught is given as minus 1, and a1 will be there as 8, and minus a is equals to a naught is equals to minus 1 and a is equals to 1, x by 1, a is equals to 1 plus x minus 6x square. So this is 7x minus 1 by 1 plus x minus 6x square. So this is the generating function. F of x is this. So this is the generating function. Now we are going to find the solution. So f of x is equals to 7x minus 1 by, or if you want to write this, or I am going to write this as, just I am taking it as 1 minus 7x, just to multiply numerator and denominator with minus 1. So I am going to write like this. So which is the generating function for the given recurrence relation? Now we are going to find the solution. So for finding the solution, we need to calculate what is f of x is. F of x is an x to the power of n summation. F of x is this. And if I am going to write this something into x to the power of n term, then I am going to comparing the coefficients on x to the power of n terms on both sides. Subsequently, I am going to get the solution for this. So for that I am going to take the right hand side in a different manner, which can be expressed as powers of 1 minus x or 1 plus x to the power of minus 1 or to the power of minus 2 or something else. So like that, for that I am going to write this is, let us consider the given equation as 1 and this generating function is 2. Now I am going to simplify this by using partial fractions. So it is x minus 1. So this is 1 minus 7x by, then I am going to write it as 3x plus 1, and then it is just I am going to take it as 2x minus 1. Simply I am going to take it as a minus 1. Then it is minus 3x plus 2x. It is minus x. Okay. So we are going to get this is. So this I am going to write by using partial fractions. So this is 1 minus 7x. 1 minus 7x by then 3x plus 1. Then it is 2x minus 1. 2x minus 1, which is equals to a by 3x plus 1, and next plus b by 2x minus 1. So of course this is a into 2x minus 1 plus b into 3x minus 1 is equals to 1 minus 7x. So of course by taking x is equals to, if x is equals to 1 by 2, then I am going to get b value. If x is equals to 1 by 3, then I am going to get a value. If I am going to get x is equals to 1 by 2, 1 minus 7 by 2 is equals to, this will be 0, b into, then it is a 3 by 2 minus 1. So it is a minus 5 by 2, then which is equals to, then it is a b by 2. b by 2. Subsequently, what we are going to get, it is x is equals to 3x, sorry, it is 3x plus 1. 3x plus 1. So I can get 5b. I can get 5b. X is, this is plus. So it is, so what I am going to get, b equals to plus 1. So once b equals to minus 1. I am just treating b equals to minus 1. Now 1 minus 7 by 3 is a into 2 by 3 minus 1. Of course, this is 0. Then which is equals to minus 4 by 3. And it is nothing but minus 1 by 3 into a. So a is equals to, a is, then what I am going to get, it is, then it is 2x, 2 into 1 by 3 minus 1. So it is minus 1 by 4. What I am going to get, a is equals to, 3 means it is 3 minus 4. Then it is minus, here x is equals to not plus x, plus 1 by 3. If x is equals to plus 1 by 3, it will not vanish. So I am taking x is equals to minus 1 by 3. So this I am going to get 7 by 3. Then it is minus 1 by 3 is minus, then this will become 3. It is a 10. 10 by 3. Then it is a 10 by 3. Then we are going to get a minus 5 by 3. It is a minus 5 by 3. So a equals to, we are going to get minus 2. So what is f of x? I am going to write it as f of x from equation 2. From equation 2, I am going to write it as, what is that? A is equals to minus 2 by, and it is 1 plus 3x. Then it is b equals to minus 1 by, or else plus 1 by 1 minus 2x. Just I took minus, I am just taking common as minus 1. So this is minus 2. Then this I am going to write it as 1 minus 1 plus 3x whole to the power of minus 1, 1 minus 2x whole to the power of minus 1. So it is minus 2 summation minus 1 to the power of n. Then this is 3x to the power of n. It is alternating series, 1 minus 3x plus 3x square and so on we are going to get. And here it is a positive term series only. So I am just 2x to the power of n. So f of n is what? Is summation an x power n. So now this I am going to term x to the power of n terms on both sides. So an is equals to minus 2 minus 1 to the power of n and 3 power n and plus 2 to the power of n. Or else I can take it as 2 into minus 3 whole to the power of n plus 1, then plus 2 to the power of n, 2 to the power of n. So this, or else I'm just taking it as, or I am going to consider it as minus 2, not minus 2, minus 1 to the power of n plus 1 and 3 power n and plus 2 power n. So this is the final solution for the given recurrence relation. So or else I can keep like this also. We can take it as. This is the way that we are going to solve a second order homogeneous recurrence relation. In the next session, we are going to solve some more problems related to the second order recurrence relations, homogeneous. Now we are going to I'm going to conclude this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.